Hello, explorers! Today we're going to do some science sketchnoting on energy with a focus on potential energy and kinetic energy. So grab your favorite shade of chartreuse, aquamarine, or razzmatazz, and let's get sketching. The title for our sketchnote is going to be Energy. And let's remember that energy is the ability to do work or cause change. Okay, there's our title. Give it a nice box around it. Now, there are two basic kinds of energy. Okay, two basic kinds. Think about it for a second. What do you think they are? Oh, correct. Potential and kinetic. Potential and kinetic. Now, let's talk about potential and kinetic for a second here. So we're going to imagine that I can skateboard. I really can't, but let's pretend for a second that I can. And here I am on my skateboard. Okay. I'm on my skateboard right here. And I start going down. Okay, and here I am moving down on my skateboard. Right. Keep moving, I'm moving. So of course I'm back up here, ready to do it all over again. I know, you're impressed, the amazing Miss Little. So when I'm doing this, when I'm up at the top, that's my potential energy, right? I'm not moving right now. It's my potential energy. And we'll talk about what potential energy is in a second. And when I'm moving, so let's not forget my hair, that's my kinetic energy. We talk about kinetic energy when I'm moving and I'm in motion here. So what exactly is kinetic energy? Okay. Kinetic energy is the energy an object has due to its motion. Right? Oops, that's not spelled right. Motion with an N. All right, motion. So we're going to draw a little ball here, and we're going to color it in with razzmatazz. I'm pretty sure half of you thought I made that color up. I didn't. It's an actual color. So our ball is moving. That's got motion. It's kinetic energy, right? The energy the object has. And if we remember kinetic energy, how we figure out just how much kinetic energy an object has, we got this great equation. And that's we take 1/2 times mass times velocity squared. And we're going to do some sample problems with squaring stuff in a minute. Let's remember for a minute though, what does it mean when I say velocity? What is velocity? We should remember from previous lessons that velocity is speed in a given direction. Right? So let's go ahead and write a lovely little car right here. My car is going super fast in that direction. It's velocity, right? So since Kinetic energy has both mass and velocity in it. Remember, though, that the more velocity, right, because we're actually taking the square of the velocity, the more velocity, the more kinetic energy an object will have. All right, potential energy, if we remember, okay, potential energy is stored energy, right? Stored energy that results from the position or shape of an object. And we're going to once again draw our little ball. Let's see, we'll put the little ball right here maybe. This time, oh, we got to remember to color it. Razzmatazz. Pink. But my ball right now is sitting on top. Let's pretend it's sitting on top of a mountain or on top of something. And it's just sitting there. But even just sitting there, it has potential to do work, right? I have potential to do work. Very excited. Who wouldn't be? I mean, right? Now, we're going to talk about two different kinds of potential energy. Gravitational potential energy and elastic potential energy. So we went to the skate park. Now we are going to go to the ski slopes. I know, it's very exciting. Fun fact, skiing is also something I really don't know how to do terribly well. So I have you friends who can ski really well. Well done. So I'm on the ski slope, and let's pretend that I am right here, and I'm at, well, let's just say 500 newtons. That's how much I weigh. And then I am with, above, and my friend is down here, right? Also skiing, ready to go. Little hat on. Also 500 newtons. Now, when I talk about gravitational potential energy, there we go. What I'm really talking about, the amount that an object is going to have is going to be dependent upon its weight and its height, how high it is. So from looking at our little drawing, oh, I should add in some snowflakes though, right? It makes it even more real. All right, so if we are both 500 newtons, me and my buddy skiing, okay? Whee! As we're going down the hill, yay. Because skier number 1 is higher up than skier number 2, who has more potential energy? Skier number 1, right, because they are higher. So, skier number 1 has more potential energy, gravitational potential energy, right? Getting on my snow hill there. Potential energy because she is higher on the ski slope. Right? Although I realize none of my skiers' feet are actually on the skis. You just have to pretend. We got that. All right, the other kind of potential energy that I want to talk about is elastic. Elastic potential energy. It's the kind of energy that's stored in a rubber band, right, when you let it go. Or, for us, we're going to talk about in a bow and an arrow. So it's the energy stored in a stretched object. So we've been at the skating park, we've been on the ski slopes. Now let's take our talents to the archery range. Okay. And our person here is got a bow and arrow. Oh, pulling back. I just got to add the hair, right? Most important thing here. There's my arrow. It's a really long arrow, apparently. And here's my target over here. I'm going to hope that I hit. Now, as my person, as she pulls back on the arrow, right, as she pulls back on the arrow, the greater the bow's elastic energy. Oh, there should be an apostrophe there. Okay, so kinetic energy, the energy of motion, of movement, potential energy, stored energy, results from the position or shape of an object. And now let's talk for a second about, how, let's put a line right here, just so you have a little bit of an idea, a little break maybe. How are energy, work, and power related? Right? We talked work about our little ball up there. So how are energy, work, and power related? So let's think about that. Remember that work is the transfer of energy. Okay, work is the transfer of energy, and power is the rate at which energy is transferred. Right, is transferred. So, well, we have a wonderful equation for that, right? Energy transferred over time gives us power. Energy transferred, oh gosh, a lot of R's, over time. And that gives us our power, okay? Real quick, let's make sure we all remember the fact when I'm talking about work, what do I mean? I'm not talking about chores you have to do around the house. You're helping, you're doing work. Home work feels like a lot of work sometimes. But when we look at the definition of work, scientifically, we're talking about a force exerted, right, on an object that causes it to move in the same direction right, the same direction in which the force is exerted. So, in which the force is exerted. And if we remember, that's why we say we're doing work when we pick up our backpack and we are moving it in the direction in which the force is exerted, up in that instance, but we're not doing any work if we're pushing on a brick wall. All right, we talked a little bit ago when we talked about kinetic energy to talk a little bit about, we said we're going to talk about velocity squared. What does that mean again? I want to remind you, what it means to square something. Well, a number in this instance. So let's imagine this is my lovely whiteboard right here, okay? And if I say 3 squared is the same as saying 3 times 3, which is equal to 9, okay? 5 squared is what? 5 times 5, which is equal to 25. All right, you now are going to do 7 squared, and in your sketch note, when you fill it in for me, tell me what that is equal to, please. Up in the corner right down here, I love math. Yay. And science, right? Thanks for sketching with me, explorers. I'm looking forward to seeing your work. And remember, keep exploring.